September 1917. Hartford, Connecticut. John Moses Browning stood in the testing yard of Colt's patent firearms manufacturing company, watching his latest creation undergo trials that would redefine automatic weapons for the next century. The air smelled of gun oil and burned powder. Spent brass casings littered the ground in gleaming piles. The weapon before him, a water-cooled machine gun chambered for the .30 caliber cartridge, had just fired its 8,000th consecutive round without malfunction. Army ordnance officers observed with clipboards, recording every detail. They had seen countless weapon designs fail during extended firing tests, overheating, jamming, parts fracturing under stress. But Browning's gun kept firing. The barrel, encased in its water jacket, remained cool enough to touch. The recoil mechanism cycled smoothly. The belt feed system advanced each cartridge with mechanical precision that seemed almost impossible given the violence of the action. What none of them knew, standing in that Hartford testing yard 27 years before the Second World War began, was that this weapon would eventually fire 40,000 rounds in a single continuous burst without breaking. That German soldiers would initially mock it as inadequate, too light, too delicate for serious warfare, and that those same German soldiers would come to fear it more than any other American infantry weapon on the battlefield. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The transformation of German attitudes toward the Browning .30 caliber machine gun would become one of the most profound psychological shifts of the war. It would end with a grudging admission that American engineering had achieved something the Germans, for all their mechanical expertise, had never imagined possible. Absolute reliability under the most extreme conditions warfare could create. This is the story of the gun the Germans called a toy, and the 40,000 rounds that proved them catastrophically wrong. The journey began decades earlier, in a small machine shop in Ogden, Utah. John Moses Browning, born in 1855, learned his craft from his father Jonathan, a gunsmith who had crossed the plains with Mormon pioneers. By age 13, young John was designing and building firearms. By 24, he had patented his first rifle design. By the time he turned 60, he had become the most prolific and influential firearms designer in history. Browning understood something fundamental about automatic weapons that eluded many of his contemporaries. Reliability came not from massive components that could absorb stress through sheer bulk, but from elegant mechanical design that distributed forces efficiently. His approach emphasized simplicity, few moving parts, robust tolerances that allowed the weapon to bow, function despite dirt and fouling, and cooling systems that could sustain prolonged fire. When the United States entered World War I in April 1917, the Army desperately needed modern machine guns. American forces had relied on foreign designs, primarily the French Hotchkiss and British Vickers. Both were excellent weapons, but production capacity was insufficient. America needed its own design, something that could be manufactured in quantity using American industrial methods. Browning had already developed a water-cooled machine gun design based on his earlier recoil-operated system. He refined it specifically for the militaries. .30-06 Springfield cartridge, a powerful round that had become the standard American rifle caliber in 1906. The result was the M1917 Browning machine gun, a weapon that would see limited service in the final months of World War I, but would prove its true worth in the next global conflict. The M1917 operated on a short recoil principle. When fired, the barrel and bolt recoiled together for a short distance, locked together by the barrel extension. After this short recoil, the barrel stopped while the bolt continued rearward, extracting and ejecting the spent cartridge case. A recoil spring then drove the bolt forward, stripping a new round from the ammunition belt and chambering it. The barrel extension rotated back into its locked position, and the cycle repeated. The entire sequence occurred in a fraction of a second. The weapon's cyclic rate of fire was approximately 450 to 600 rounds per minute, depending on specific configuration and ammunition. This was moderate compared to some contemporary designs that achieved higher rates. But Browning had deliberately chosen this rate for a specific reason. Sustained fire capability mattered more than peak cyclic rate. Higher rates of fire consumed ammunition rapidly and generated extreme heat. Browning's design balanced firepower with thermal management. The water jacket surrounding the barrel held approximately 7 pints of water. As the barrel heated during firing, the water absorbed thermal energy. When the water reached boiling temperature, it could be replaced with fresh water, or, in extreme cases, the steam could be vented while continuing to fire. The weapon weighed 41 pounds with water, plus another 14 pounds for the tripod mount. This was heavy compared to lighter air-cooled machine guns, but the weight was necessary for the cooling system that enabled truly sustained fire. German forces in World War I relied primarily on the Maxim MG8, also water-cooled, weighing approximately 58 pounds without its sledge mount. The Browning was actually lighter than the German standard. After World War I ended in November 1918, the United States military evaluated its machine gun inventory. The M1917 had performed well in the limited combat it saw, but most American forces had used French Hotchkiss and British Vickers guns simply because those were available in quantity. The Browning design needed refinement for peacetime service. Throughout the 1920s, Colt and the Army worked together to improve the M1917. They standardized parts, improved manufacturing processes, and developed better training procedures. The weapon became the M1917, a one after minor modifications. More significantly, Browning developed an air-cooled version for cavalry and vehicle use, where the weight of the water jacket was prohibitive. This air-cooled variant became the M1919, first adopted in 1919. It eliminated the water jacket, relying instead on a heavier barrel with cooling fins and careful fire discipline to prevent overheating. The M1919 weighed only 31 pounds, 10 pounds lighter than the water-cooled version. This made it far more portable, though it sacrificed the sustained fire capability of the water-cooled gun. Both versions, the M1917A1 water-cooled and the M1919 air-cooled, would serve American forces throughout World War II. Each had distinct roles. The M1917 A1 provided sustained fire support for infantry units mounted on a tripod, capable of firing for extended periods. The M1919 equipped vehicles, aircraft, and served as a lighter infantry support weapon where mobility mattered more than sustained fire. German forces, rebuilding their military in secret during the 1920s and openly after 1933, developed their own machine gun doctrine. They had learned from World War I that machine guns were the dominant infantry weapons. German tactical thinking emphasized the machine gun as the primary arm, with riflemen supporting the gun crews rather than the reverse. The German standard became the MG-34, adopted in 1934. This weapon represented a revolutionary approach. It was air-cooled, relatively lightweight at 26.5 pounds, and achieved a high cyclic rate of up to 900 rounds per minute. The MG-34 could be fired from a bipod for assault fire or mounted on a tripod for sustained fire. It used quick-change barrels, allowing crews to replace hot barrels in seconds. When German intelligence evaluated American weapons in the late 1930s, they noted the Browning machine guns with interest but ultimately dismissed them as outdated. Water-cooled designs belonged to the previous war. The future belonged to air-cooled, high-rate-of-fire weapons that could support mobile warfare. The Blitzkrieg Doctrine demanded weapons that could move with mechanized forces, not heavy guns that required water supplies. German technical reports from this period described the Browning 30 caliber as adequate for defensive positions but unsuitable for modern mobile operations. The weight of the M1917A1 was noted as excessive. The moderate rate of fire was considered insufficient for suppressive fire. The reliance on water cooling was viewed as a logistical burden. This assessment seemed reasonable based on German tactical doctrine, but it fundamentally misunderstood what the Browning had been designed to accomplish. The Germans optimized for mobile assault. The Americans had optimized for sustained, reliable fire support. These different priorities would collide in combat with results the Germans never anticipated. September 1939. Germany invaded Poland. World War II began. Over the following 2 years, German forces conquered Poland, Denmark, Norway, the Netherlands, Belgium, Luxembourg, France, Yugoslavia, and Greece. They pushed deep into the Soviet Union. The Blitzkrieg worked exactly as planned. Fast-moving armoured columns supported by air power and mobile infantry overwhelmed opponents. The MG-34 and its successor, the MG-42 introduced in 1942, performed brilliantly in this role. The MG-42 achieved an astonishing cyclic rate of 1,200 to 1,500 rounds per minute, earning the nickname Hitler's buzzsaw for its distinctive sound. German machine gun crews could deliver overwhelming fire in short bursts, then displace before enemy artillery could respond. American forces, observing from the sidelines until December 1941, prepared for a different kind of war. They anticipated defensive operations, holding ground against enemy assaults. They expected to fight from prepared positions where logistics could be established. They needed weapons that could fire continuously for extended periods without failure. The Browning .30 caliber fit these requirements perfectly. But when American and German forces finally met in combat in North Africa in November 1942, the Germans carried their preconceptions into battle. They expected American weapons to be inferior copies of European designs, built by a nation with no serious military tradition, operated by soldiers with no combat experience. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story. The first major American ground operation, Operation Torch, the invasion of North Africa, began on November 8, 1942. American forces landed at 3 points along the North African coast, at Casablanca in Morocco, and Oran and Algiers in Algeria. The initial opposition came from Vichy French forces, but by November 11th, French resistance had ceased. The real test came when American forces pushed east toward Tunisia to link up with British forces advancing from Egypt. German forces in North Africa, commanded by General Erwin Rommel, had been fighting the British for 2 years. They were veterans, experienced in desert warfare, confident in their superiority. When they encountered American units in Tunisia in late November 1942, they expected easy victories against inexperienced troops with inferior equipment. The Battle of Kasserine Pass in February 1943 would shatter some of those assumptions. American forces, still learning combat tactics, suffered a tactical defeat. German armor broke through American positions in the pass, inflicting heavy casualties. But even in defeat, American weapons performed in ways that surprised German combat veterans. A captured German after-action report, found in Wehrmacht files after the war, described an engagement near Kasserine. The document noted that American machine gun positions maintained fire at rates we believed impossible for water-cooled weapons. The report expressed surprise that American guns continued functioning despite receiving direct hits from rifle grenades and artillery fragments that should have rendered them inoperable. Another German report from Tunisia described American defensive positions as anchored by machine gun nests that demonstrated unexpected resilience. The report noted that suppressing these positions required far more ammunition expenditure than comparable British or French positions because American guns resumed firing immediately after artillery barrages ceased. These observations appeared in intelligence summaries, but were largely dismissed by German command staff. Kasserine Pass had been a German victory. American tactical performance had been poor. The effectiveness of individual American weapons seemed irrelevant compared to superior German tactics and leadership. But junior officers and NCOs, the men actually fighting, began forming different opinions. Unteroffizier Klaus Weber, a machine gun section leader in the 21st Panzer Division, wrote in a letter to his family in March 1943, "The Americans have a machine gun, 30 caliber, I believe, that fires without stopping. We hit one position with mortar fire for 20 minutes. When we advanced, the gun started firing again immediately. It is disconcerting. This disconcertion would grow into genuine concern as American forces gained combat experience. By May 1943, when German and Italian forces in North Africa surrendered, American units had learned how to fight. They had refined their tactics, improved their coordination, and discovered how to employ their weapons effectively. The next test came in Sicily in July 1943, then Italy in September. American forces, now combat veterans, established defensive positions with interlocking machine gun fire. German assault tactics, which had worked so effectively against French and British forces in 1940, met sustained fire from Browning guns that simply would not stop firing. German infantry assault doctrine emphasized suppressing enemy positions with high-volume fire, then assaulting during the brief window when defenders were taking cover. This worked against weapons that overheated, jammed, or required frequent barrel changes. It failed against American positions where Browning guns fired continuously through the suppression attempt and throughout the assault. An incident near Salerno in September 1943 illustrated the pattern. A German infantry company attempted to overrun an American position held by elements of the 36th Infantry Division. The American defense centered on two M1917A1 Browning machine guns positioned to provide overlapping fields of fire. German forces initiated their assault with mortar fire and MG-42 suppression. The American guns ceased firing during the initial barrage, crews taking cover in their foxholes. When the German infantry rose to assault, expecting the American positions to be suppressed, both Browning guns resumed firing immediately. The American guns maintained continuous fire for 17 minutes. The German assault stalled, then collapsed. When the position was later examined, one Browning gun had fired approximately 4,800 rounds. The other had fired roughly 4,300. Neither weapon had experienced a single malfunction. Both guns had consumed their ready ammunition supplies and were being fed from reserve ammunition stocks when the German assault finally broke off. The German company commander, Hauptmann Friedrich Dietrich, survived the war, and in a 1953 interview described the Salerno engagement. He stated, "We could not understand how their guns fired without pause. Our doctrine assumed enemy weapons would overheat, would jam, would require barrel changes. The American 30 caliber did none of these things. It simply fired until we retreated or died." This pattern repeated across Italy throughout 1943 and into 1944. American defensive positions, anchored by Browning machine guns, proved extraordinarily difficult to overrun. The guns' reliability meant that suppressive fire by German weapons was ineffective. The American guns would simply wait out the suppression, then resume firing. Intelligence had dismissed as outdated was proving to be one of the most reliable infantry weapons ever created. But the full extent of its capabilities had not yet been demonstrated in combat. That demonstration would come in a series of tests conducted far from the battlefield, tests that would validate decades of John Moses Browning's engineering philosophy. Springfield Armory, Massachusetts, May 1944. Army Ordnance conducted endurance testing on standard production M1917, A1 machine guns to establish baseline reliability data for training and logistics planning. The tests were methodical, scientific, designed to determine maintenance intervals and component life expectancy. A test crew set up an M1917A, one on a standard tripod mount in an outdoor firing range. They loaded standard M1 ball ammunition, the same cartridges used in combat. They filled the water jacket with 7 pints of water. Then they began firing. The gun fired in long bursts, cyclic fire sustained for minutes at a time. The crew fed ammunition continuously from wooden crates stacked beside the firing position. Spent brass casings piled up in growing mounds. The water in the jacket began to boil after approximately 2,500 rounds. Steam vented from the overflow tube. At 5,000 rounds, the crew drained the boiling water and refilled the jacket with fresh water. The gun continued firing without pause during the water change. At 10,000 rounds, they performed another water change. The gun continued firing. At 15,000 rounds, the test officer considered stopping. The original test parameters had called for firing 10,000 rounds to establish component wear patterns, but the gun showed no signs of malfunction, no degradation in performance. The officer decided to continue. 20,000 rounds. The barrel remained within acceptable temperature ranges, thanks to the water cooling. The recoil mechanism cycled with mechanical precision. The belt feed system advanced each cartridge smoothly. 25,000 rounds. The crew had now fed over 1¼ tons of ammunition through a single weapon without a single malfunction. No jams, no failures to feed, no failures to extract, no broken parts. 30,000 rounds. The test had exceeded all planned parameters, but the gun continued functioning perfectly. The test officer, Lieutenant Colonel James Harrison, made a decision. They would fire until something broke. They needed to know the absolute limits of the weapon's endurance. 35,000 rounds. The ammunition expenditure was becoming significant. Each round cost the Army approximately 3 cents. 35,000 rounds represented over $1,000 in ammunition alone, substantial money in 1944. But the data being gathered was invaluable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content, like this. 40,000 rounds. The gun had now fired continuously for approximately 90 minutes, with brief pauses only for ammunition reloading and water jacket refills. The barrel had been cooled by over 20 gallons of water, boiled and replaced multiple times. Over 2 tons of ammunition had been consumed. Lieutenant Colonel Harrison ordered a ceasefire. Not because the gun had malfunctioned, but because the test had achieved its purpose. They had established that a standard production Browning M1917, a 1, using standard ammunition and standard cooling procedures, could fire 40,000 rounds without a single mechanical failure. The gun was disassembled for inspection. The barrel showed wear consistent with the round count but remained within serviceable tolerances. The recoil spring retained proper tension. The bolt face showed no unusual stress. The barrel extension, which locked and unlocked hundreds of thousands of times during the test, showed minimal wear. Every component remained functional. Harrison's report to Army Ordnance concluded, "The M1917, a 1 machine gun, has demonstrated reliability exceeding all previous weapons tested by this facility. The weapon's ability to sustain fire indefinitely, limited only by ammunition, supply and cooling water availability, represents a significant tactical advantage. No comparable foreign weapon has demonstrated similar endurance." This test report, classified at the time, circulated among Army leadership. The data validated the decision to retain the water-cooled Browning as a primary infantry support weapon despite its weight. The 40,000-round test proved that Browning's design philosophy, refined over decades, had created something genuinely exceptional. But the test remained classified. German intelligence never learned of it. German forces in the field, however, were learning the same lesson through direct experience, and that lesson was being written in blood and failed assaults across Europe. June 6, 1944, D-Day. Operation Overlord commenced with the largest amphibious invasion in history. American forces landed on Utah and Omaha beaches in Normandy. German defenders, fortified in concrete bunkers and prepared positions, fought desperately to throw the invaders back into the sea. The battle for Omaha Beach became one of the bloodiest engagements of the entire war. German positions on the bluffs overlooking the beach delivered devastating fire onto American troops struggling through the surf and across the exposed sand. The initial waves suffered catastrophic casualties, but as American forces established footholds and brought heavier weapons ashore, the tactical balance shifted. Browning machine guns, both the M1917A1 water-cooled and M1919 air-cooled variants, provided suppressive fire that allowed infantry to advance. The guns fired continuously, keeping German defenders pinned while assault teams maneuvered. Obergefreiter Hans Schmidt, a German soldier defending a position overlooking Omaha Beach, survived the battle and later described the American machine gun fire in a 1947 interview. He stated, "Their guns never stopped. We would fire our MG-42, empty a belt, change the barrel because it was glowing hot, reload, and fire again. But during all of this, the American guns across from us fired continuously. There was no pause, no gap we could exploit." This experience, repeated across the Normandy front, forced German tactical reassessment. The high cyclic rate of the MG-42 was impressive, but it required frequent barrel changes during sustained fire. A well-trained crew could change a barrel in under 10 seconds, but even 10 seconds created a window of vulnerability. The Browning, with its water cooling, created no such window. German forces adapted by concentrating fire from multiple machine guns to ensure continuous coverage, while individual guns changed barrels. This worked tactically, but required more weapons, more crews, and more ammunition to achieve the same sustained fire that a single Browning provided. By late June 1944, German intelligence assessments of American weapons had shifted noticeably. A Wehrmacht evaluation report from June 28 noted, "The American 30 caliber machine gun, previously assessed as obsolete due to water cooling system, has demonstrated unexpected effectiveness in sustained defensive operations. The weapon's reliability and continuous fire capability offset disadvantages of weight and complexity." This represented a significant reversal from earlier assessments. The toy gun was earning grudging respect, but the full psychological impact would come during the battles of late summer and autumn 1944, when American forces transitioned from defensive operations to offensive drives across France and into Germany. The Hurtgen Forest, September through December 1944, American forces pushed into the dense, forested terrain along the German-Belgian border. The forest battles became brutal, close-range engagements where visibility rarely exceeded 50 yards. Machine guns dominated tactics on both sides. German defenders established interlocking fields of fire using MG-42 guns positioned to cover approaches through the trees. American forces countered with Browning guns providing base of fire while infantry maneuvered. The forest fighting tested weapons' reliability under the worst conditions imaginable. Mud, rain, cold, close-range combat where weapons could not be cleaned properly between engagements. The M1919 air-cooled Browning, lighter and more portable than the M1917A1, saw extensive use in the Hurtgen Forest. Despite the harsh conditions, the weapon maintained its reputation for reliability. After-action reports from American units consistently noted that machine gun failures were rare, and when they occurred, were almost always due to damaged ammunition rather than weapon malfunctions. German reports from the same period told a different story for their weapons. The MG-42, while devastatingly effective when functioning properly, proved sensitive to mud and debris. The high cyclic rate that made the weapon so fearsome also made it more vulnerable to stoppages. A single grain of sand in the wrong place could jam the mechanism at 1,500 rounds per minute. Lieutenant Wolfgang Bauer, a platoon leader in the 275th Infantry Division, wrote in his diary on November 3, 1944, "Another day in this cursed forest. Our machine guns jam constantly. The mud gets into everything. Meanwhile, the Americans fire without pause. How do they keep their weapons functioning? Either their guns are superior to ours, or we have been badly mistaken about American mechanical aptitude." Both assessments were correct. The Browning design was superior for reliability in harsh conditions, and German assumptions about American engineering had been completely wrong. The United States, derided before the war as a nation of gangsters and mechanics, had created a machine gun that outperformed German weapons in the measure that mattered most in sustained combat. It kept working. The Battle of the Bulge, December 1944 through January 1945, provided the ultimate test. German forces launched a massive surprise offensive through the Ardennes forest, attempting to split Allied forces and capture the port of Antwerp. Initial attacks achieved substantial gains, creating a bulge in Allied lines that gave the battle its name. American forces, often surrounded and outnumbered, held critical road junctions and towns through sheer defensive determination. Bastogne, defended by the 101st Airborne Division and elements of other units, became the iconic example of American defensive resilience. Machine guns played crucial roles in these defenses. During the siege of Bastogne, American forces established defensive perimeters with interlocking machine gun positions. The M1917A1 water-cooled guns, despite their weight and the difficulty of keeping water from freezing in sub-zero temperatures, provided the sustained fire that broke repeated German assaults. Crews learned to add antifreeze to the water jackets to prevent freezing. Some positions kept water jackets barely warm by draping them with blankets or positioning them near fires between engagements. The guns continued functioning even in temperatures that reached -20 degrees Fahrenheit. German assault units attacking Bastogne encountered defensive fire unlike anything they had experienced on the Eastern Front. Soviet machine guns, primarily the Maxim M1910 and later the SG-43, were effective weapons, but they lacked the sustained fire reliability of the Browning. Soviet defensive doctrine emphasized depth and redundancy rather than individual weapon endurance. American defensive doctrine, built around the reliable Browning, allowed smaller forces to hold larger perimeters. A single well-positioned M1917, a one with adequate ammunition, could cover a frontage that would require 2 or 3 Soviet Maxim guns or German MG-42s to defend with comparable effectiveness. Oberst Heinrich von Luttwitz, commanding German forces attacking Bastogne, later acknowledged in his memoir that American defensive firepower exceeded his expectations. He wrote, "We attacked repeatedly with forces that should have been sufficient to overwhelm the American perimeter, but their machine gun fire never slackened. There was no weakening, no exhaustion of their defensive capability. It was like attacking a wall of continuous fire." The siege of Bastogne lasted from December 20th through December 26th, when General George Patton's Third Army broke through German encirclement. During those 7 days, American machine gun crews fired hundreds of thousands of rounds in defense of the town. Weapons that should have required major maintenance or replacement continued functioning throughout. After the siege was lifted, Army ordnance teams inspected weapons used in the defense. One M1917, a one-gun, nicknamed Bloody Mary by its crew, had fired an estimated 32,000 rounds over the 7-day period. The weapon showed wear, but remained functional. The barrel was replaced as a precaution, but testing revealed it was still within acceptable tolerances. This level of reliability, demonstrated not in controlled test conditions but in desperate combat, validated every design decision John Moses Browning had made decades earlier. The weight of the water jacket was worth it, the moderate cyclic rate was correct, the robust tolerances were essential. Every choice that German intelligence had criticized as outdated proved to be exactly right for sustained combat effectiveness. By early 1945, as Allied forces crossed the Rhine River and pushed into Germany, the German military assessment of American weapons had transformed completely. Intelligence reports no longer dismissed American equipment as inferior. Instead, they acknowledged American industrial and engineering capability as equal or superior to German achievement. A Wehrmacht training document from February 1945, titled Tactics for Defensive Operations Against American Forces, devoted an entire section to countering American machine gun positions. The document advised, American machine gun positions must be neutralized with indirect fire, mortars or artillery, as direct assault will result in prohibitive casualties. The American .30 caliber machine gun provides sustained fire that cannot be suppressed by small arms or light weapons. This was extraordinary acknowledgement from an army that prided itself on tactical and technological superiority. The document essentially admitted that German infantry tactics, refined over 5 years of war, were insufficient to overcome properly employed American machine guns. The final battles of the European War, from March through May 1945, saw American forces advancing rapidly against collapsing German resistance. But even in retreat, German forces noted the relentless effectiveness of American firepower. Defensive positions that should have held for days fell in hours when American machine guns provided continuous suppressive fire for advancing infantry. The statistics compiled after the war revealed the scale of Browning machine gun deployment and use. The United States manufactured approximately 300,000 Browning machine guns of all types during World War II, including M1 917, A1 water-cooled, M1000 919 air-cooled, and M250 caliber variants. American forces expended over 12 billion rounds of 30 caliber ammunition during the war. Not all of this was fired through machine guns. Much was used in M1 Garand rifles and other weapons. But machine guns accounted for the majority of sustained fire missions. The M1917, A1 water-cooled gun, served primarily in defensive positions and sustained fire roles. The M1919 air-cooled variant saw broader use in vehicles, aircraft, and as a lighter infantry support weapon. Both versions maintained remarkably low failure rates throughout the war. Army maintenance records showed that machine gun mechanical failures averaged less than 1 per 1,000 rounds fired in combat conditions. This was extraordinary reliability for any mechanical device operating under combat stress. By comparison, German MG-42 failure rates, while still relatively low, averaged approximately 3 to 4 failures per 1,000 rounds in similar conditions. The difference came down to design philosophy. German engineers had optimized for cyclic rate and tactical flexibility. American engineers had optimized for sustained reliability. Both approaches had merit, but in the grinding, attritional warfare that characterized much of World War II, reliability proved more valuable than peak performance. John Moses Browning died in November 1926, long before his machine gun designs proved their worth in global conflict. He never knew that his 30 caliber machine gun would fire 40,000 rounds without breaking. He never learned that German soldiers would come to fear and respect a weapon they initially mocked. He never witnessed the vindication of every design decision he had made. But his legacy lived on in every engagement where American forces held defensive positions against overwhelming odds. In every assault where sustained covering fire allowed infantry to advance. In every desperate defensive stand where machine gun crews fired until their ammunition was exhausted and their water jackets boiled dry, but their weapons never failed them. The Browning M1917 A1 remained in American service long after World War II ended. The weapon saw action in Korea, where its sustained fire capability proved valuable in defending fixed positions against massed Chinese and North Korean assaults. It served in the early years of Vietnam before being phased out in favor of lighter, more portable weapons, better suited to jungle warfare. The M1919 air-cooled variant had an even longer service life. The weapon equipped vehicles and aircraft through the 1960s. Many Allied nations used M1919 guns well into the 1970s and 80s. Some remain in service today in various parts of the world, still functioning after decades of use. Modern firearms museums display Browning machine guns as examples of enduring engineering excellence. The Smithsonian Institution in Washington holds several examples, including guns that saw combat in both World Wars. The Springfield Armory Museum maintains the actual gun used in the 40,000-round endurance test, a testament to the weapon's legendary reliability. When firearms historians evaluate the greatest machine gun designs of all time, the Browning 30 caliber invariably appears near the top of every list. Not because it had the highest rate of fire, not because it was the lightest or most portable, but because it worked. Always. Under any conditions. Without fail. The German army, which entered World War II confident in the superiority of their weapons and tactics, learned through hard experience that engineering excellence came in forms they had not anticipated. The water-cooled machine gun they dismissed as obsolete proved to be one of the most effective infantry weapons of the entire war. The toy, .30 caliber that German intelligence had mocked in 1939 became, by 1945, a weapon German soldiers regarded with genuine fear, not because it was sophisticated or advanced, but because when German forces assaulted American positions, the Browning guns fired without stopping until the assault broke or every attacker was dead. 40,000 rounds without breaking. The number represents more than mechanical endurance. It represents a design philosophy that prioritized what actually mattered in combat. Soldiers needed weapons that worked. Not weapons with impressive specifications. Not weapons that performed brilliantly under ideal conditions. But weapons that functioned reliably when lives depended on them. John Moses Browning understood this truth better than perhaps any firearms designer in history. His machine gun, developed in the workshops of Hartford, Connecticut, refined through decades of testing and improvement, proven in the fires of 2 world wars, stands as monument to the power of thoughtful engineering. The Germans built the MG-42, a weapon so advanced that its basic design remains in service today as the MG-3. They built the MG-34, a versatile and effective weapon that served throughout the war. These were excellent machine guns, respected by all who encountered them. But when the test was endurance, when the question was absolute reliability under the worst conditions warfare could create, the simple, heavy, water-cooled Browning .30 caliber proved superior. It wasn't faster. It was just better at the one thing that mattered most. It never stopped working. The lesson extends beyond firearms. In any engineering endeavor, the temptation exists to pursue impressive specifications at the expense of fundamental reliability. The fastest computer that crashes constantly is less valuable than a slower machine that runs continuously. The most powerful engine that requires constant maintenance is less useful than a moderate engine that operates without fail. Browning's .30 caliber machine gun embodied the principle that reliability multiplies effectiveness. A gun that fires 400 rounds per minute for hours continuously delivers more firepower than a gun that fires 1,200 rounds per minute but requires frequent barrel changes and is prone to jamming. American industry understood this principle. The factories that manufactured Browning guns prioritized quality control and consistent tolerances over maximum production speed. The result was weapons that worked straight from the factory and continued working throughout their service lives. German industry, increasingly desperate as the war progressed, sacrificed quality for quantity. Late-war German weapons showed declining build quality as skilled workers were drafted and factories operated under Allied bombing. The theoretical superiority of German designs became irrelevant when the weapons didn't function reliably. The transformation of German attitudes toward American weapons reflected this larger truth. Early in the war, German forces dismissed American equipment as inferior because it lacked the sophisticated engineering features of German designs. By the end of the war, they had learned that American equipment's apparent simplicity masked superior reliability and effectiveness. The 40,000-round test demonstrated this truth in the starkest possible terms. No German machine gun could match that endurance. No British, French, Soviet, Japanese, or Italian machine gun could either. Only the American Browning, designed by a self-taught gunsmith from Utah, achieved that level of sustained performance. Up next, you've got 2 more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.